Welcome. Today we are going over notes 3.7a, factoring by division. So the idea behind this lesson is we're going to use division to help us try to factor our polynomials. So here's a basic example, 154 divided by 7. So let's think back to how we learned how to do division. So you have 7, you have a little division box, you have 154. So 7 does not go into 1. How many times does it go into 15? Evenly. So twice. So then what would we do? 2 times 7 is 14, and then you would subtract. 15 minus 14 is 1, and then you bring down the 4. So 7 doesn't go into 1. Does it go into 14? Yes. How many times? 2. So then it's 2 times 7, which is 14. You subtract. You get 0. So 7 goes into 154 22 times. Your remainder is 0. Sometimes you would write it as 0 or 7. A lot of times you would not write the remainder. So just depending on how you learn how to do division. Now let's do 7 into 156. So 7, we have 156. So 7 doesn't go into 1. It goes into 15 twice, evenly. So 2 times 7 is 14. Subtract. You get 1. Bring down the 6, and then you repeat. 7 goes into 16. Doesn't go in evenly. It goes in twice. Right? So again, 7 times 2 is 14. You subtract. You get 2. So it's 22 with a remainder of 2. Or maybe you can also rewrite it as a remainder of 2 over 7. So basically what we're doing is, say we have 5 times something equals 10. I want to know what that is. Well, I know that this is 5, and I know it equals 10. So to solve, right, we would do division. So that's what we're going to be doing. I'm going to give you an expression. I know it multiplies to give me something else. I need to find that missing piece. So we're using division. So here's an example. This is what we call polynomial long division. So I'm going to divide just like we did on the last two examples. So I'm trying to figure out, I know x minus 2 times something equals x squared plus 2x minus 7. I want to figure out what is that missing something. So we're going to use division. Right? Just like up here, if I said 5 times what is 10, you would find that out by dividing by 5. That's how you would figure it out. Well, that's the same logic that we're going to use. So here are the steps. Right? First off, both polynomials should be in the largest exponent terms first. So x squared and x. So they need to be in descending order. So x squared, x, and so forth. Divide the first term of the numerator by the first term of the denominator and put that in your answer. Multiply the denominator by the answer and then put that below the numerator. Subtract and create a new polynomial. Repeat. So it'll make more sense when we actually do this. So we have x plus 2. That's in descending order. And x squared minus 3x minus 10. That is in descending order. So what do I mean by descending order? You start with the largest exponent and then you move down from there. The constant should be at the end. So, first step, right? X and x squared. So how many times does that go? Does x go into x squared? Well, x times what is x squared? X. So then I do x times x, which is x squared. And then x times 2, which is plus 2x. And then I subtract. Same idea that we did with regular division. So again, x goes into x squared one time, right? Because x and x is x squared. And then I multiply x times both of these. And now I subtract. So x squared minus x squared, 0x squared. Minus 3x minus 2x gives me minus 5x. And then I bring down the negative 10. And then I repeat the same process. So x is going to go into 5x minus 5 times. So then I multiply. Minus 5 times x is minus 5x. Minus 5 times 2 is minus 10. And I subtract. So be careful here with the negative signs. Minus 5x minus a minus 5, that becomes minus 5x plus 5x. So that's 0. This becomes minus 10 minus a negative 10, double negative. So it's negative 10 plus 10, so that's 0. So your remainder is 0. So it's asking, is x plus 2 a factor? Yes, it is. Because the remainder is 0. That's when it's a factor. So what we figured out is that x plus 2 times x plus 5 equals x squared minus 3x minus 10. So we use division to find our missing factor of x plus 5. So it is a remainder. It's a factor if the remainder is 0. All right, so let's look at example 2. So we want to know if it's a factor. Well, that's if the remainder is 0. If it's not 0, then it's not a factor. So we have x minus 3. We have 2x squared minus 5x minus 11. So again, in descending order, right? 2x squared, 5x, 11. So x goes into 2x squared. Now, if you can't figure that out, well, what do you have to multiply x by to get 2x squared? 2x. So then it's 2x times x. 2x squared, 2x times negative 3 is negative 6x, and then I subtract. So 2x squared minus 2x squared is 0x squared. Minus 5 minus a negative 6, that becomes double negative. So it's plus, so this becomes 1x. Then you bring down the 11, and you repeat. X goes into x how many times? 1 time. And then again, you multiply. So 1 times x is 1x. 1 times negative 3 is negative 3. Subtract. So 1x minus 1x is 0x. Minus 11 minus negative 3, that becomes to double negative, so it becomes minus 8. So that is your remainder. So is it a factor? No. Right? Because the remainder is negative 8. It should be 0 in order to be a factor. Okay, so moving on. So example 3 and 4, we're actually going to apply it to things that we're going to be using it for graphing. So we're going to divide using long division so we can factor. So right now, right, if we're looking at this, we don't really have a method in order to factor it, right? It's not a trinomial, right? GCF, no. Maybe factoring by groupings a possibility. We could maybe try that. Not guaranteed that's going to work. But it says that we do have x minus 7 as a factor. So I can use that to do my division. So I have x minus 7. And then I have this polynomial. So x to the third minus 12x squared plus 41x minus 42. So basically what's happening is I know x minus 7 times something is going to equal this long polynomial function. That something is what I'm trying to figure out. And by doing this, by dividing by a factor, I'm going to end up getting something that I can factor. So in this case, it's going to technically end up being a trinomial. but I'm going to get a trinomial that I can factor. So I'm using division to find a trinomial that I can actually factor. So x goes into x to the third twice, right? So x squared, multiply it by both. So x squared minus 7x squared, and then I subtract. Be careful with your signs. So x to the third, oops, that should be x to the third, becomes 0x to the third. 12x squared minus a negative, that's a double negative, so it becomes a plus. You're adding 7x squared, but that's still going to give you minus 5x squared. Bring down the 41x and repeat. So this is gone, it's 0. So x goes into 5x squared minus 5x times, and then you multiply. So you get minus 5x squared minus 5x times minus 7 gives you plus 35x, and then you subtract. So again, be careful with your negative sign, right? The negative distributes, so this double negative, this becomes positive. So this ends up becoming negative 5x squared plus 5x squared, which is 0x squared. And then 41x minus 35x is going to end up giving you 6x. Bring down the negative 42. And repeat. So x goes into 6x 6 times. So this is plus 6. Multiply. So 6 times 6x is 6x. 6 times 7 is minus 42. And then we subtract. Right? This becomes 0x. Negative 42 minus minus. So that becomes plus 42. So this becomes 0. So there we go. My remainder is 0. So what I just figured out is that x minus 7, the factor I started with, times x squared minus 5x plus 6, that equals my large trinomial, or not trinomial, polynomial, that we started with. So I use division to find this trinomial that I can now factor. So x minus 7, now just like we've always done, we can factor the trinomial, right? X and x, multiples of 6 that add to give me 5. So that would be 3 and 2, minus minus. And that equals the large polynomial. So now we're in factored form. I can find my x-intercepts, right? I could set this equal to 0 and find my x-intercepts. So I took an expression that was in standard form, used division to get it into factored form. And again, hopefully as you're going through this, you realize if I tell you it's a factor, right, then that means the remainder has to be 0 because you're dividing by a factor. So your remainder has to be 0. If you don't get 0, then you mess something up. So keeping that in mind, we can go to example 4. Now it says x minus 1 is a 0. So we have standard form here. We want to get it into factored form using division. So since it's a 0, I want to use the factor. So if x minus 1 is the 0, then the factor would be x plus 1. And we have x to the third plus 4x squared. It's in descending order. So there we go. So again, same idea. What we're trying to figure out is there's x plus 1 times some trinomial equals our big polynomial. I'm trying to find that missing trinomial by using division so that I can factor it and get this from standard form to factored form. So we're going to repeat just like we've been doing. How many times does x go into x to the third? X squared. Multiply. X to the third. Multiply. Plus 1x squared. Subtract. Again, being careful with your signs. X to the third minus x to the third is 0. 4x squared minus 1x squared is plus 3x squared. Bring down the negative 15x, and then we repeat the same process again. How many times does x go into 3x squared? 3x times. Multiply 3x times x, 3x squared, 3x times 1, plus 3x. Again, if you're doing this correctly, notice that these values should always be the same, because when you go to subtract, there should be 0. So this is going to give you 0x squared. Minus 15 minus 3 is now minus 18x. Bring down the minus 18. And then repeat the same process again. How many times does x go into negative 18x? Negative 18. So you get negative 18x. Negative 18 times positive 1 is negative 18. I'm going to subtract. Again, being careful with your signs, right? You're going to get double negative, so 18 plus 18 is 0x. Negative 18 minus 18 becomes plus 18, so plus 0. And there we go. There's my remainder, which hopefully makes sense because we were dividing by a factor. Your remainder needs to be 0. So now I have my trinomial. So now I use division to get a trinomial that I can now factor, and now I'm going to be in factored form so that eventually I can find my x-intercepts. So x squared is x and x. I need multiples of 18. That will give me 3. So that would be 6 and 3. So plus 6 minus 3. So there we go. Now you're completely factored. Right? Now we can continue on, set equal to 0, find our x-intercepts, and eventually sketch. So again, this is factoring by division. This is what we call polynomial long division. Make sure you answer the essential question at the top of the notes, right? When you're writing your summary. Remember, your summary should be 3 to 5 sentences long. Have a great day.